Today we're talking about impulse, and we're going to address these two questions. How is impulse calculated, and what does impulse result in? So to get an equation for momentum, we're going to look at a warm-up problem dealing with a rocket. And we have a force making the rocket accelerate for t seconds, and we want the final momentum. Well, remember that momentum is mass times velocity, so if we can get the final velocity, then we can find the momentum. Well, I know that v final equals v0 plus at, and I know that F equals ma, so A is equal to the force divided by the mass. And if I substitute that into this, I get V final equals force divided by mass times time. And then I can bring that back over here, and I can get that my final momentum is equal to the mass times the force divided by the mass times the time. Or what I get, if I look at this, the mass cancels out. It doesn't matter what mass, I have the same momentum at the end. And since my initial momentum was 0, what I really have is the change in momentum is going to be the force times the time. What I'd like you to do now is take a moment to research impulse. You can use your book or Google or whatever resources you have and just find two things about impulse. To get our impulse equation, we're going to start with what we commonly do in Newton's second law, sum of the forces equals ma. And we're going to rewrite acceleration as a change in velocity over change in time. So then that leaves us with F equals m, change in velocity over change in time. And what I'm going to do is I'm going to bring this m inside the change here, and then I now have F equals the change in mass times velocity over the change in time. But remember that mass times velocity equals momentum. So what we really have here is the force equals change in momentum over change in time. And what I can do is rearrange these variables and get change in momentum equals a force times a change in time. And that's going to be important because impulse is a force applied for some amount of time. And impulse results in a change in momentum. So because of this, we get two equations for impulse. And also with impulse, we have a variable that we're going to use. We can't use I. We're going to use the variable j for impulse. So we get impulse, by definition, is force times the change in time. And impulse results in a change in momentum. So we can use either of these, the definition of impulse, force times time, or the result of impulse, change in momentum, to find out the impulse on an object. You might think of the word impulse like when you're standing in line at the grocery store and you don't think real quickly and you just grab a couple candy bars as you're going to pay. Or a quick decision to buy a new pair of jeans. Or a nice new t-shirt. The units for momentum can be found by following the equation. Force times time, we could have Newton seconds, or change in momentum. And remember that our momentum units are kilograms times meters per second. Although these may appear to be different units, they're actually the same, because if we think about what a Newton is, remember a Newton comes from F equals ma, so that's a kilogram times meter per second squared. And if we multiply that value times a second, one of these seconds units goes away and we get kilograms times meters per second, which matches the other. The idea is that impulses are usually quick applications of force over some amount of time. And these forces cause a change in momentum in the object. Quantities Here are the rules from the Rocket Club contest from several years ago. The main idea was we had to get our rocket to go 750 feet and be in the air from 48 to 50 seconds. But what I wanted to point out here is the rocket motor total impulse limit of 80 Newton seconds. So we should be familiar with that because we know that impulse equals force times time, which is newtons times seconds. So when we're building a rocket, we have to pay attention to the impulse from our engines. And here's a graph that shows the thrust, or the newtons, times time. And notice that's not exactly constant. If you look here, an A engine motor, which is this pink down here, is very short and not much time. When we continue on, the B engine motor, B, has a very big spike, but then it runs out quickly. So it actually has the most force, but it doesn't last for much time. Then we can look into the D engine motor. That's this red value here. It spikes not quite as big. Look, it continues to go on. And just like before, anytime we're multiplying quantities, we're looking at the area underneath the graph. So if we're doing force times time, we're looking at the area of a force versus graph time. And you can see how much more area the D engine has than what the A engine had when it spiked straight up and came right back down. All right, the first question here says, what is the impulse of this force? And as we just talked about, if we have a graph of force versus time, impulse is the area trapped in the graph. So we want the area of this triangle. So for number one, we do area of a triangle is 1/2 base times the height, which is 1/2. The base of this thing is 0.5 seconds. Remember, these impulses usually don't last very long, but they can, times 150 newtons. So the impulse is 37.5 Newton seconds. Now the second question asks, what is the change in momentum? Since we just found the impulse, and remember that impulse is force times time, but impulse results in a change in momentum. So how much impulse you did will also be the change in momentum. So that's 37.5, and you could do Newton seconds or you could do kilograms times meters per second, because that's usually what we talk about with momentum. Then we want to know if this force is positive, what would be the final velocity? So what we can do is we could say that change in momentum is momentum final minus momentum initial. And we know that our change in momentum is 37.5 equals momentum final we don't know, but we do know our momentum initial. And remember that P equals mv, so that's 30 times 5 meters per second. So that's 150. So then if we want our final, we add 150 to both sides. And we get momentum final equals 187.5. But remember, we want what is the final velocity. So if we want the final velocity, well, this is mass times velocity final equals 187.5. And the mass is 30 kilograms. Velocity final 187.5. So divide both sides by 30, and we get the final velocity. We get about 6 1/4 meters per second. So let's summarize what we learned. What are two ways to calculate impulse? Remember, impulse is defined as force times a change in time, but impulse can also be found because it results in the change in momentum of an object. So that helps out with question number 2. What does an impulse result in? Well, remember, impulse results in change in momentum. How can a smaller force result in more impulse than a larger force? Well, because impulse is equal to force times a change in time, we could have a big force times a little bit of time. But if we have a small force times a large change in time, we could get a bigger impulse from that. And how can you determine impulse from a force versus time graph? Well, remember, if we have a force versus time graph and it shows what the force did, remember that the impulse is the area under the curve. Thanks for following along with this impulse lesson. Please give me a little bit of feedback of what you thought. Thank you.